Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Taqiyya Najla Syarif with student number 2206829950. Today I'm going to presenting my final exam answer for numerical method class. From the previous video, I already explained for the number 1 and 2 and 3. So in this video, we're going to move on to the number 4. This is the question number 4. We're going to solve this question with the framework called J5. We're going to solve it with day 5. This is the intention. The goal is to understand the behavior of the STD trailer when the hairstyle Defender FN-M3P high-powered machine gun is mounted and fired, causing vertical motion. We need to model the system, estimate the damping coefficient, and determine if the trailer will stabilize or reach the point of structural failure. Additionally, we will evaluate if the system is experiencing resonance or beats and assess the risk of compromising the structural integrity of the truck. Okay, the first is initial thinking to approach this problem. We have four. The first one is data plotting, which means plot the given displacement data to visualize the trailer's motion and describe the observed behavior. And the second one is damping coefficient estimation, which means use the displacement data and a mathematical model to estimate the damping coefficient by minimizing the sum of squared errors, or SSE. And next, resonance or beats, which means analyze the system to determine if it is experiencing resonance or beats. And then the last but not least, structural integrity, which means assess if the trailer's displacement will exceed the shock limits 0.5 meters if the weapon is not turned off. Okay, this is the idealization. We have model assumption and equation of motion. In model assumption, we know that the mass of the hairstyle defender, spring constant of the shock, force due to the weapon firing, displacement data provided over time, and initial condition. For the equation of motion, the differential equation for the damped harmonic oscillation with an external force is given by the slide. This is the instruction set. The step 1 is plot the data and describe the behavior. Given the displacement data over time, plot the data to visualize the trailer's behavior. In here, I use Python. We're going to describe the behavior. From the plot, describe the oscillatory behavior of the trailer, not the amplitude and frequency of oscillation and any trends over time. Okay, the step 2 is estimate the damping coefficient using the given data and the differential equation model. Estimate the damping coefficient beta by minimizing the sum of squared errors, or SSE, between the observed data and the model's prediction. In here, I use Python, and we're going to describe the estimated damping coefficient. Use the optimized value of beta to describe the estimated damping coefficient. And step 3 is resonance or beats. Analyze the solution to determine if the system is experiencing resonance or beats. This can be done by examining the frequency components of the displacement data and comparing them to the natural frequency of the system. In here, we got the natural frequency and the force frequency. Compare the natural frequency and the force frequency to determine the presence of resonance or beats. We can compare it by Python. And then step 4 is structural integrity assessment. Discuss the comparison and using the estimated damping coefficient, simulate this system to determine if the displacement exceeds the 0.5 meter limit. We can use Python too. And then the summary of the instruction set is summarize the findings from each step and provide a conclusion on whether the undamped shock are sufficient and if the trailer will reach the point of structural failure if the weapon is not turned off. discuss the importance of the damping coefficient and the potential presence of resonance orbits in the system.